Good afternoon, guys. Welcome back to the orchestration of frameworks, LLM frameworks. Today, we're going to discuss a very interesting framework, which is Haystack framework. So let's talk about the components. Okay. So this diagram represents the Haystack observability framework designed for distributed tracing, monitoring, alerting, and visualization of microservices-based applications. Let's break it down layer by layer for clarity. This is a distributed observability architecture using components like Apache Kafka, various for tracing and visualization. Apache Kafka is Let's try and deep dive into each of the components for explanation. First comes the Haystack agent, where you have sidecar proxy, which is attached to the services, which captures the local spans, that is units of work in a trace, enriches metadata like service name, time, host. It buffers and forwards the data to Kafka. Think of it as a data collector at the source or the service level. Then comes the Haystack collectors. These will receive the span data from different agents. This is an entry point for telemetry, and it sends it to the Kafka for further processing. This will act as a consolidate data and forwarder to the Kafka itself. Now, Kafka is the central message bus. It's basically the backbone for intercomponent communication. It will manage message querying. It will do topic partition queues, decoupling the producers and consumers, replayability and scaling. Then we have Haystack traces. They will reconstruct the traces by collecting spans. Part span is to useful info, and this will get stored in Cassandra for long-term span storage, and Elasticsearch for quick search. It allows filtering and querying of the trace data. This will enable deep tracing of request flows across microservices. Then we have Haystack trends. This will aggregate the spans into metrics like latency and errors. This will generate time series data. It sends to the metric tank for time series storage, metric aggregation, trend analysis, and it will help us track the performance trends over the time. Then we have Haystack adaptive alerting. This will allow for anomaly detection using moving averages, seasonal variations. Let's talk about Haystack adaptive alerting. So anomaly detection using moving averages, seasonal variation, custom rules is done here. It sends real-time alerts to alert subscription modules, useful for detecting unexpected behavior in services. Haystack service graph. Why do we use this now, right? So Haystack service graph will build a real-time dependency graph of the services. It will identify service interactions, caller-callee relationships, microservice topology. It's great for understanding microservice relationships visually. Then we have Haystack pipes. This will route the Kafka data to external sinks like S3 bucket of AWS and several other data lakes. It will provide archival support, optional analytics extensions, non-blocking data flow. This will ensure observability of data, and observability data can be repurposed or archived externally. Finally, we have the Haystack UI itself. This is a central visual dashboard. It will show traces, alerts, metrics and trends, service graphs. You can search and drill down. These capabilities are there. It will interface for DevOps and SRE teams. All components feed into this UI for real-time visibility and debugging. Storage and backend systems. There is Elasticsearch, fast search and indexing for trace data. We can use Cassandra for scalable storage of raw span data, and metric time series backend for storing trends and metrics, Grafana compatibility, right? So data lifecycle, if I just give you a summary of the data lifecycle, the first step would be it spans the data collected by Haystack agent from services. Next step would be Haystack collector send these things to the Kafka. Third step is Kafka fans out the data to Haystack traces, Haystack trends, Haystack service graph, Haystack adaptive alerting, Elasticsearch with Cassandra, and metric tank alerting the engine, Haystack UI for visualization. Key benefits of this architecture are it's Kafka centric, so you can scale. It's basically scalable, decoupled, and real time. Modular Haystack nodes will allow for specialized processing and flexibility. Elasticsearch and Cassandra in combination will allow for fast search and scalable storage. Metric Tank and Grafana will allow for visual time series analytics, alerting and abnormality detection. Basically, real time operational awareness can be there. Then we have the extra added UI layer, which will help for DevOps friendly dashboard with traceability. So this is the framework of Haystack. Now let's get into the code of the Haystack framework as well. And I'll show you an example data set that we have taken for this purpose. And example data set that we're using is basically a text file, a very simple text document, okay, which has some information about uterine fibroids, how the diagnosis and treatment is done. A very short text file is taken here. On this, we are going to perform certain tasks. So the first thing is we're installing the required libraries. And let's go through the code of this Haystack framework one by one, right? Okay. This notebook sets up the RAG, which is Retrieval Augmented Haystack Pipeline, for answering questions over a text file. So let's break down some steps. First one is we're trying to install Farm Haystack, which is a powerful framework for building NLP pipelines. Sentence transformers, which will provide embedding models for semantic similarity search. And Quiet, which suppresses the verbose installation output. Okay. Next step is we are going to import certain modules. So we're importing certain modules here. Again, in-memory document store will allow you to store the documents temporarily in memory. Embedding retriever, this will retrieve the documents based on vector similarity. Prompt node will generate answers using a language model. Preprocessor will break down the text into smaller chunks. Pipeline, this will link the retriever and together. Document, this step 3, we're basically uploading our text file in question. So we can retrieve the name of the uploaded file. We can select a file here and upload. I have already selected the text file and uploaded it here. Then we have step 4, where we're reading the file content. This will read the full content of the uploaded text file into the variable content. So it will store it in this particular variable, right? Okay. The next step is to create and initialize the document store. This will create an in-memory store. Embedding dimension is 384. This matches the output size of chosen embedding model, mini-LM. Okay. Now, pre-processing the text. Obviously, that's the step. This will wrap the content into a document object. It is using the preprocessor to break down the text into chunks of 80 words. That's what we mentioned, right? 80 words. And it will add 10 words of overlap for context continuity. Okay. And we're trying not to split middle of the sentence. So we're maintaining that boundary here. And this will write the processed chunks into the document store. The retriever. This will embed the chunks using mini LM model. It will update the embedding. Update underscore embeddings is basically going to store the vector representations of each chunk for retrieval later on. Right. Then we come to the 8th step where we're defining a prompt template and prompt. This defines a RAG style prompt template using natural language. And user will find the relevant terms and prompt to answer the question in the first place. We're giving, we're defining the Q&A function. The last and final step is where we're testing out our prompts and answers. The answers are getting retrieved by RAG when we question, right? So you can see here the first question is, what are uterine fibroids? And it's giving the answer, they are common benign neoplasmas, right? And it's also extracting the snippet where it finds this answer. So uterine fibroids are common benign neoplasms with a higher prevalence in older women and those in African women, right? It's basically giving me the snippet also from where it's fetching the answer. What are the symptoms that can cause fibroid? Again, it's showing abnormal uterine bleeding, pelvic pressure, bowel dysfunction, frequency and urgency, urinary retention, and it's also showing me the snippet that it's got from the document itself. The third question, for what are the treatments that are available for uterine fibroids? Simple answer, I don't have enough information to answer this question because it did not find the answer to this question. It's responding inappropriately, right? What is the preferred initial imaging modality for fibroids? It's giving a simple answer, ultrasonography is used. And it's also fetching the snippet from where it gives this answer. So this is how we can use for Q&A, Haystack framework as an NLP application. This is it for now. Thank you so much. Stay tuned with us. In the next session, we'll be discussing few more frameworks, a lot of interesting orchestration frameworks in LLM. Don't forget to subscribe, like, and comment. Thank you.